Hello, welcome. In this video, I'm going to go over assignment 1. So let me just share my screen here. Yay, yay. Eventually, I will share my screen. Oh, here it is. Share my screen. All right, so I'm going to go over the answers for assignment 1. So let's get started. All right, so let's start here. These are sample solutions, and I will make comments as I go. And so I already posted a document that did have some sample solutions, but I will go over it and discuss them. So here's question 1. So the universal set, so the way that let me make sure my pen has the thing. Okay. So the universal set, that means it includes all the numbers from 1 to 10, including 1 and including 10. So what that would mean is that if the set S are the numbers 1, 4, 6, 8, 9, then the set S complement is going to be 2, 3, 5, and 10. Whoops, I forgot 7. 7's also not in there. So what that means is that if you were to put together S1 with S1 complement, then you would get the universal set. All right, so we have S1 and then we have S2. S2 is 2, 4, 5, 8, and 9. So to compute the union, what does the union mean? The intersection is not the same as the union. If you were to do the intersection, you would pick those that are in only those that are in both sets. So if we were to do the intersection, we would have 2, 5, and I think that's it. But this question doesn't ask for the intersection, it asks for the union. So to compute the union of the complement of S1 union with S2, that's going to include everything that is in this set and also in this set. So we have 2, 3, 4, 5, 7, 8, 9, and 10. So basically, the only numbers that are not in the union of S1 complement with S2 would be the number 6 and the number 1. If I asked you to do the union of S1 and S2, that would be different. You would include the number 1 and you would include the number 6 because that's part of S1. But this question didn't ask that. It asked for the complement of S1. Okay, the next question. Here you want to compute the Cartesian product. So to do the Cartesian product of S1 with S2, all you do then is make the ordered pairs, and this is ordered. So keep in mind that S2 with S1 is not the same thing as S1, S2 because they are ordered. So you would just go ahead here and make a new set that are the ordered pairs. And you just start out like with 1, and the first ordered pair would be 1, 2. The next ordered pair, so you go 1, 2, then the next ordered pair would be 1, 4. The next one would be 1, 5. The next one would be 1, 8. The next one would be 1, 9. Then you move on to 4 and you make the ordered pairs between that, which would be 4, 2, 4, 4, 4, 5, 4, 8, and 4, 9. And you continue on and on and on doing the ordered pairs between each element in this set combined with one in that set. So I don't think you really need to watch me do all of that. Just keep in mind that the product of S1 with S2 is not the same thing as S2, S1. S2, S1 would be going the other direction. You would start here and have your ordered pair that way. So it would be 2, 1, 2, 4, etc. But that's not what the question asked. The question just asked for you to compute S1 with S2. All right, next. So now we want to get into directed graphs. In this class, we're going to start doing DFAs. I'm going to show you, here's an example of a DFA. We're not going to call these vertices, we're going to call them states, and we're not going to call them edges, we're going to call them transitions. So this is going to be an initial state. You're going to make a transition maybe with an A and go to this state. So this is just getting you used to the concept of directed graphs. So I'm I'm just I don't know what I'm doing here. I'm just making something else here. So I'm just giving you an idea. So this represents a DFA, and we're going to be doing that in module 2, but you will notice that it is a directed graph. So just in practicing, we're going to be doing directed graphs for the rest of the semester. We're going to do DFAs and NFAs and NPDAs and LBAs and Turing machines. So we are going to be doing directed graphs. So I just wanted to make sure you have a good understanding of the directed graphs. I just want to point out that when we get started, we're going to call these, I'm going to call these states and transitions. And here we're going to have vertices and edges. So edges are directed. These are directed. It means that they have an order. It starts in V1 and goes to V1. This starts in V1 and goes to V2, starts in V2 and goes to V3, etc. All right, so you're going to have 3 vertices, V1, V2, and V3. Now keep in mind, this is stuff, if you weren't paying attention, this is module 2 stuff. This module 1 stuff is just getting you ready for module 2. Then you look at the edges. So I start in V1 and I go back to V1. That's this edge right here. Now I have an edge that starts in V1 and goes to V2. Notice that they are directed. They have arrows. Then I have an edge that starts in V2 and goes to V3. And I have one that starts in V2 and goes to V1. And I have one that starts in V3 and goes to V1. So this is the answer for this question. Let me get another color here because I want to point something out. This is a cycle. All right, so we're going to have cycles. You will see here in my DFA, I have a cycle here. And that's going to be important to understand and recognize cycles. This is a cycle and this is a cycle. In this graph, this is a cycle and this is a cycle. All right, so you need to recognize what cycles are in graphs. You need to recognize what states or vertices are and directed edges and the direction that the edges go in. But this right here is the answer for this question. All right, now we want to do a graph directed that has 5 vertices and 10 edges. There's not only one answer for this question. So I'm going to give you a sample answer. I'm going to draw my 5 vertices. I'm labeling them V1, V2, V3, V4, and V5. So we need to make 10 edges, 10 directed edges. So if I do like 1 and this, that is not acceptable for this because that creates a cycle. So the rules are I have to have no cycles. So that means if I have an edge that goes from V1 to V2, I cannot have an edge that goes back from V2 to V1. So I'm going to start by putting edges around here. I have one from, this is 1, 2, that's not making a cycle, 3, that's not making a cycle, 4, and 5. Again, there's not only one solution, but this is the solution that I'm giving you. All right, so now I'm going to, if I put a edge from here to here, that follows the rules as long as I don't put an edge going back. All right, so now I have 6, I have 7, I have 8, I have, let's see, if I go from here, 9, that's going to work. And if I go from here to here, that's going to work. That's not the only solution. That's just one solution. You could have had, instead of this edge going here, you could have put one going this way, right? As long as you don't have a cycle going back and forth, like this creates a cycle, one edge this way, one edge going back, that would not follow the rules. All right, now let's go to question 5. So question 5 is just understanding notation as far as strings, where we're going to be using W to indicate a string. We're going to have alphabets. So alphabet, like on alphabet A, B, you can create by combining the symbols of the alphabet, you can create strings. So this is just getting used to you understanding notation that we're going to be using throughout the semester. But at any time, if you have any questions, please ask. So we're going to take substrings and create one long string. So we're going to create a longer string that is made up of this string. And in this case, the alphabet is AB. It doesn't matter if the alphabet is AB because we're not going beyond that, but I'm just introducing some and reviewing some of the other topics. So if your string is AABBAB, then what this stands for is that string you have, that is the reverse of that string, and then that is that string. So you're just going to concatenate those three together to make one long string. So we would do AABBAB. That would be our string. Then I'll get another color here for the reverse. Then the reverse would be BABBAA. And then we get another color here, AABBAB. So this right here is WWRW. If I asked you to do WRW, it would be a different string. If I asked you to do WWW, that would be concatenated 3 times together. All right, so now once we've created this string, it's the same string for the next question. Now you want to look through it and see how many times you have substrings of AAB. So let me get another color here. All right, so we can go through here and take a look. AAB. We have an AAB right here. So that's one substring of AAB. No, 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 no. And here we have another substring of AAB. So the answer to question 5B would be that we have 2 substrings. Oops, I'm still on highlighter mode. I gotta get back to pen. Would be that we have 2 substrings of AAB, and it would be nice to like highlight it and indicate those substrings. All right, question 6. So question 6, this is just getting again used to the concept of languages. So assume we have an alphabet AB. Alphabet, we're going to be doing this all semester. This would be our alphabet AB. So if I said your language is L star, L star means every single possible combination you could make of AB. That would be the definition of a language, would be everything I could make out of AB. Another thing I could do is I could say, okay, my language equals A. So that means that in my language, the only thing in my language is the string which contains one symbol A. So the definition of this language right here is that this language consists of one single A, 2 B's, or ABA. So this is a language that has 3 strings in it. So this is a language with 3 strings. Okay? So that's it. That's my language. My language has 3 strings, but I can take the star of that language, and in order to take the star of that language, what that means is I can concatenate these strings that are in my language. Also with the star, that also includes the empty string, which we will be doing a lot this semester as well. All right, so I can concatenate these substrings in my language in any way, infinitely number of times. So some strings that would be an L star based on this language right here, some strings, let me get a different color, would be A, B, B, A, B, A, also the empty string, A, B, A, B, 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 A. This is an infinite language. So any infinite ways that I can combine the strings in my language are part of L star. Oops. So then you just take a look at these strings right here, right? So when we take a look at these strings, I can concatenate ABA, A, oops, another ABA, the single A, and an ABA. So that means that, yep, this string is made up of the concatenation of these strings that are in my language any number of times. Then I go here. I concatenate A with A with A with ABA. Oops, now I got to a point where I have a B here. So this does not follow the rules of concatenating B, B, ABA. So this string is not part of L star. And I can look at this right away and know that this one's not part of L star because there's no single B. The only single B that's in my language must have an A in front of it. So this one is also not part of L star. And this one, take a look. I have BB with an A, with an A, with an A, with an A, with an ABA, with an A. So yes, this one is part of L star, and this one is also part of L star. So that's the answer to that question, those two. Now, what does L4 mean? L4 means that I take the strings in my language and I concatenate them 4 times. So if I concatenate them more than 4 times, they're not going to be an L4. So I gave you the same strings. So we know we have the same language and the same strings. So we know that this one is not in the language. And we know that this one is also not in the language because they're the same strings and they can't be made by concatenating the strings of our language. But this one has 1, 2, 3, 4 concatenations. So this one is in L4. This one has 1, 2, 3, 4, 5, 6, 7 concatenations. So this one is not going to be an L4, but it is in L star because L star is an infinite number of concatenations. So that's the answer to question 6. All right, question 7, you got a freebie on part A. You just look at the back of the book for the grammar. I will tell you that grammars are difficult to create. I know that they're difficult to create. They're difficult to grade, but we will be doing grammars in this class. We need to understand grammars, but in assignment 1, I decided to give you how to generate strings from a grammar. So if you remember a grammar is made up of variables, which are usually uppercase letters, terminal symbols, which are usually lowercase letters, a start symbol, which for the beginning, you don't have to start with S, we just do. So it's a start symbol. And then you have a series of production rules. So what I want you to do is look up in the back of the book and find the grammar on alphabet AB. That is a grammar that will so grammars are used to generate strings. So we want a grammar that's going to generate strings that have exactly 2 A's. So if you, on alphabet AB, you can say, okay, what are some strings that would be in the language? Well, the string BAA would be in the language because it has 2 A's. The string ABA would be in the language. The string AA would be in the language. The string BBA, BBBA would be in the language. The string ABAA would not be in the language because it has 3 A's. The string AB would not be in the language because it has 1 A. So we're going to learn about languages and rules for languages. And this is just kind of, introduction here, but we're going to be doing that throughout the semester. So you're, you were asked to look in the back of the book and find the answer for this. So the answer in the back of the book, you have your productions. So that's what I wanted you to put here, the productions that are going to generate strings on alphabet A, B, and all the strings that it generates will have exactly two A's. So you would start, so you have to pick up your two A's. So you have to have two A's. Every string in this language has to have two A's. You can have any number of B's or nothing in front of it. You can have any number of B's or nothing in between the A's, and you can have any number of B's or nothing in at the end. So when you start out, you have to at least get your two A's. Then you have a couple of choices for what happens in front. In front, you could go to lambda. If you go to lambda, that just means here. If you go to lambda, that just means on the production, you replace that A with nothing. That variable goes away. Remember that when you do a grammar, you want to produce strings. You produce strings, you want to get rid of all of the variables, and you do that by replacement. You start out and you do this production right here, and then you take each one of these A's that is here, and you have to replace them. I kind of did a shortcut on that answer. Um, but you, but so for each A, you can either replace it, like in this case, you're just going to replace the A, replace the A, replace the A, or you can pick up B's. So each time you can pick up as many B's as you want. So you can continue, and grammars is something that takes time to get used to, but right now I just want you to understand how to generate strings from grammars. So you should have looked up this answer, looked at my example, and then tried to generate these two strings. So let's generate the strings. Let's generate this string first. Okay, so I'm going to do it. I'm not going to do it shortcut way. I'm going to do it very kind of a long way. I'm going to start out. You must start with your first production. This is my first production. I'm picking up my two A's. Now, you can see here that my two A's are going to be at the beginning of the string, so I can go ahead and get rid of these A's. So in my next production, I'm going to have two A's at the beginning because I'm going to replace this A with lambda, which is one of my productions, and I'm going to replace this A with lambda. So when I do that, it's going to get rid of those two A variables and leave me with two single A's at the beginning. And now I have an A. All right. So I'm leaving this A here so that I can go slowly through the steps. So this A, now I'm going to put a B there because I need to pick up a B. So in this production, I'm going to have A. I'm going to take that A right there and replace it with a BA. So I picked up one B. I need to pick up three B's. So I'm going to replace this one again. So I'll have AA, the B that I already got, and I'm going to pick up another B. Then I'm going to have to pick up a third B. So I'm going to have A, B, 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 A. And then I can finally replace this with lambda. And I have generated the string that was asked for in the question, which is A, B, B, B. Then to generate the other string is going to be a little different. I still have to start with the same start. I have to pick up my two A's. But this string is going to have a B in the beginning. So I'm going to replace this one. I got to pick up my B here. So I'm going to take that A and replace it with a BA. I'm going to leave my little a. And so on this one, I'm also going to pick up a B because I need to have B's in there. So I'm going to pick up a B here. And then I'm going to leave my little a. And then on this one right here, I'm going to lambda that one out because it ends with an A. So I've gotten my two A's here. I've gotten my 1B at the beginning. So on my next production, I can replace this one with lambda. So I have B, A, and I can pick up another B here. So you always leave your terminal symbols in your string. So I have a B. I'm going to pick up another B here. And then I have my A at the end. And then I just need to lambda that one out. And I will have B, A, B, B, A. Okay, so hopefully this helps you understand a little bit more about grammars and grammar productions. And if you have any questions, please ask. Also reach out to the TAs and that's it.